Okay, recording started. So this week is lesson 8. So congratulations, you've made it all the way to the end of the course. We will have one more week for those of you who would like to try doing your own project. It's optional. And if you do it, I'm happy to help you out during the week. And a week from today, we can get together, and those of you who do a project can show us what you've done, what you've worked on. And there's no pressure. If you only got partway there or didn't get as far as you'd hoped, it's no big deal. There's only like 3 or 4 of you on the call right now, so I don't know what kind of turnout we'll get, but it's available to you to take advantage of if you'd like to. What I thought we would do tonight is basically look at how to apply Python in the data science domain, and I'll clarify what I mean by that term. And we'll also take our app that we've been working on for the last few weeks, and we'll take it to the next step, which is to try to deploy it. We'll clean it up a little bit, restructure some parts of it, and deploy it on the web, so you can actually connect to it directly from my version or your version. You can actually connect to from your own computer. The notebook is mco.fyi/pi8 tonight, and I'll put that link in the chat. And as usual, go ahead and make a copy. Make your own copy of that one from File, save a copy in Drive. The first thing I'm going to do is to use pip install to install 4 packages that will depend on this week. So I thought it might be nice to just get that out of the way up front. So run that first cell. And we'll dive into the data science piece, and we'll do it in 3 parts. I think of data science as, this isn't original, I stole this from somebody else, but I think of data science as an overlap between coding skills, statistical / machine learning skills, and domain means domain-specific knowledge. So like if you're using data science to solve business problems, obviously it helps to know a lot about the business you're working in. Or if you're using data science to do bioinformatics or some kind of scientific process, it helps to know about that domain. So knowing something about the problem space, knowing something about the statistics and the math of data science, and knowing how to code is a killer combination. If you can get those 3, then you're, I think, putting yourself in a place where you can be very valuable and contribute something good. So let's just walk through 3 examples of data science. And the first one is comes from an online site called Kaggle. So if you're interested in machine learning at all, you should know about Kaggle. Kaggle is a site where basically data scientists kind of live. It's kind of like, it's almost like Facebook for data scientists. So people will, let me make sure I let Radha in. Hi, Radha. And Cerulean. Hi, Cerulean. If you go to this Kaggle site, you can set up an account of your own, and you have access to a bunch of different resources. One of the most interesting ones is the, let me blow this up and do the same on this one before I forget. One of the most interesting things, and probably the thing that made Kaggle as well known as it is among machine learning people and data science people, is these competitions. So you will see the summary of the competition. Look for one that's interesting. Google Research Football with Manchester. Train agents to master the world's most popular sport. So you'll basically see a challenge like this. You'll see prize money, and you'll be able to join the competition. And then you can look at the leaderboard and see who's winning. It's very competitive, obviously, but don't let that turn you off. I've actually not done these competitions myself. I just like the learning resources to see how people are solving these problems. Sometimes these prizes go way up, like they've had $1 million prizes on this site. But the other really interesting thing is they have a lot of data sets. So if you're just looking for data on a particular topic, it's a good place to look. And then they have these notebooks, and these are a lot like the Colab notebooks we've been working on. They're just a slightly different implementation, but they're all based on this thing called Jupyter. So for the most part, you'll find these notebooks work kind of like you would expect. Actually, we're going to look at a typical one in a minute, but here's Pandas cheat sheet. So Pandas is something we're going to talk about a little bit later, but here's somebody who's written a notebook just to show you something like 131 different tasks in Pandas, cell by cell. So lots of great resources here. And of course, you can search for notebooks that fit a profile you're interested in. I recommend this site if you're at all into data science. So that's where I got the notebook I'm going to work through with you right now on gender pay gap analysis. It's going to use this library I just mentioned called Pandas. And what Pandas is basically it gives you the ability to create Python data structures that kind of operate like a spreadsheet, that have columns and rows, and you can refer to the columns and the rows by number and name and stuff. It's just a really nice, you can almost think of it as a list on steroids, where you can reference the different subsets of the data and do operations on it and graph it. So if you do any kind of data analysis in Python, you'll want to know about this library called Pandas, and we'll actually use it in a minute. Okay, so let's jump in. First, we're going to import some dependencies. One of the things you'll notice we're importing is Pandas, and we're going to call it PD just so that we can save on typing. We're also importing Matplotlib and Seaborn. That's for visualizing data, and NumPy is for doing numerical processing. We're going to set two options in Pandas. That just tells Pandas, give us everything, all the rows and all the columns. Don't try to summarize when we print out anything. And the first thing we're going to do is read in a data set. So I've got this data set called Inc. OCC, occupational, gender, CSV. So I think the Inc is income for different occupations by gender. And this CSV means that it's a comma separated value file. So it's a text file where each field has a comma between it. And so that's how Pandas knows how to parse the text into fields and eventually into a bigger structure. So we call PD dot, so Pandas method, read CSV, and we give it a pointer to where the CSV file lives. Now this is a funny URL you've probably never seen before. It's not HTTPS, it's GS, which is just a special name for storing things in Google Cloud. We have a Google Cloud storage system, which is, if you've ever heard of Amazon S3, it's like that. If you haven't heard of it, don't worry about it. It's just a way to reference a file that lives in the cloud. So I give this URL, and it's basically like saying, go get that file, and any values that are not filled in, label them with the string NA, and then take the results of that and put it in a variable, connect it with a variable called df, and df stands for data frame, which is the name of this type in Pandas. Okay, now we've got a data frame with all the stuff we want. Let's look at the first 10 rows. So we can just print df:10. The nothing before the colon, as you probably remember, means start at the beginning. So it's essentially 0:10. And we see the first 10 rows numbered from 0 through 9. And we see the fields in this data frame. We have occupation, which is all these different types of jobs. We have all workers. That's the number of worker for each occupation. All weekly, that's the average weekly income for these different occupations. Then we have the number of male workers and female workers, male weekly and female weekly. So you get the idea. We're going to try to look at how the male and female incomes compare for similar occupations. We can also reference just columns by name in a data frame. Like we can say print out the occupation column and the all weekly column. So that would give us like a whole list of occupations with the average weekly income for those across everyone. And that's exactly what we see here. So you can get a sense for all the different occupations. We've got tax preparers, web developers, statisticians, all this stuff. So quite a few, and along with the weekly salaries. Now, a lot of these have NaN, not a number, which means apparently there was no data for those particular types of occupations. So this is a typical case where you have this data that you got from somewhere, but you really need to check it out and make sure it doesn't have, weird values that are going to throw off your calculation. And so we call that data engineering, or just cleaning up our data. And Pandas has some nice capabilities for doing that. So what we can do, for example, is let's just do part of this. So Pandas data frames have a field called, or a method called isNA, which means is that field null or not applicable, and then sum all the fields. So we're going to print the number of fields that have NAs and it does it nicely by columns right here. So we see occupation and all workers are fine, but all weekly has a few hundred. M weekly and F weekly also have over 300 NAs. So what we can then do is you run a method called drop NA, which sounds like what it's going to do. And then we can do the same thing and see what happens. We can print the count. And now you see the number of NAs went to 0 across all those columns. So now we know we've sort of cleaned things up for those values. I'm going to reset the index. That just means using the NA, now that we got rid of the NA values, reset those row numbers and everything so that it all lines up as we would expect for the filtered set of data. And we're also going to sort all the data based on the all weekly field. Now, since we already did this, it probably doesn't hurt to do it again. Yeah, I forgot to get rid of that. And we get it sorted by all weekly. And as you can see, these row numbers are sort of random because of the fact that we sorted this stuff. And so if you look at the all weekly column, you can see it is sorted from what looks like the highest to lowest weekly income. And of course, if you look at the occupations, this tells you the most highly compensated occupations: chief executives, pharmacists, lawyers, physicians, and surgeons. Nothing too surprising in there. I guess pharmacists I wasn't expecting to be that high, but that's interesting. Now, so that's kind of, you're not going to do the same thing every time with every data set, obviously, but that just hopefully gives you a sense of how you can use Pandas to load some data into a frame, examine it, and clean it up. All with Python. And the nice thing about doing it with Python is, unlike doing it in a spreadsheet where you sort of manually do a bunch of steps, and then if you have to redo it, you have to remember what all the steps were. By doing it programmatically in Python, you can automate it. You've got a script somewhere. If you get a new version of that data set or a slightly different data set, you just run your script and it does all this cleanup for you. You don't have to do much work. Next thing we might like to do is to look at the data. So we're going to do some graphing now. And we're going to use this module called Seaborn. I'm going to first set a few global things. I'm going to say I want the pastel color codes, purely aesthetic choice there. Lots of other options available. I'm going to set 2 plots side by side, and I'm going to adjust their space. So these 3 lines are really just kind of fine-tuning the look of the graphs, but I'm not doing anything yet to make the graphs actually be produced. The next couple steps will do that. So first thing we do is we gather all the male data, and we do that by sorting the values for M weekly in an ascending order, and we take the top 20. And then we do the same thing for the female data, where we take the F weekly column, sort it, and put the top 20 into this female data variable. And then we do print those 2 pieces of data, those 2 data sets, in a bar plot. And this shows you how easy it is to make a bar plot with Seaborn. You tell the F, or rather the X and Y labels. Well, actually, it's the columns in the data frame for the X and Y axes. So there's a column M weekly and there's a column occupation, and we want the occupations in the Y-axis and the male weekly pay along the X-axis. The data is just the data frame to take that stuff from. The label is how to label it, obviously, and the axis is where we want the data to be plotted. And then we just say fig show. So let's run that. And we get 2 graphs. The one on the left is for men and the one on the right is for women. And if we look at this, we can see the first 2 for men and women are the same. The third is physicians and surgeons. So yeah, you can sort of eyeball this, but you can't get too much out of it by doing this kind of staring and comparing between two different graphs. But the thing I guess I wanted to emphasize here is that this really is just getting the data into buckets that I want to compare. I really was able to generate 2 bar charts with just 2 lines of Python. And granted, I set some things up here, and obviously I'm manipulating the data, but it's very powerful. And this is sort of like an important theme. Once you know the basics of Python, most of the time you're just using things, you're gluing things together that other people built. So you don't have to really be an expert or know how to do. I mean, you can just, if you know how to use things and you know about which things to use, and half the time you have to find it, it's not going to be something you already know, then you don't actually have to be that deep into Python. You just have to know how to like put these pieces together like we're doing here. Okay. So what I'd really like to do is to compare these 2 and have one graph that would help me understand what the differences are. So in Pandas, it's as easy as saying, make a new column in this data frame called difference and set that equal to this column, M weekly, minus this column, F weekly. So what that's going to do is for each occupation, tell me the difference for the male compensation versus the female compensation. And then I can generate a bar plot with that, showing the difference. And I'll also do ascending equals true. So I'll get both like the top down and the bottom up. So let's look at that. And we see now the top one. So the top one is the careers with the occupations with the biggest difference. So this is male minus female. So a positive difference means the average male man in this data set is making more than the average female in that same occupation. So it's essentially which occupations are most unbalanced towards men. And we see legal, personal financial advisors, another kind of financial category, so for some reason, finance and legal seem to, here's another financial analyst one. And then we can look at the other end of the spectrum and say, which are the occupations where this number is most negative, which means like the difference is such that the women in that occupation are earning more than the men. And we see there are a few. 5. And we can see which ones they are. But looking at the top 10 and the bottom 10, so to speak, or the top 10 in each direction, kind of left me wondering, well, how many do we have? Because I know after we cleaned them up, we still had probably hundreds, and I'm only seeing 5 here going in that direction. So how could we count that? And it's easy enough to do. We just run the sum function on all of the differences, the data frame differences, for which that difference value is less than 0, and we call that the negative count. And then we do the same thing for where that I is greater than or equals 0, and we call that the positive count. I guess I should call these like, I'll just leave it what it is for now, but basically the negative count is where women are out earning men, and the positive count is where men are out earning women. I shouldn't call them negative and positive because it sounds like it has a value judgment, which is the opposite of the value judgment I would want to convey. But let me proceed here because I'll just screw my code up if I fix it now. So the total length is 142. That means there are 142 occupations in this data set. And you might be wondering why that's so small. It's because of all those NA values that we purged previously. Now the positive count, or the number of occupations where men were out earning women for the same occupation, is 137. The negative count is 5. So we already knew there was going to be a small number on that side. So, 142 over, 5 divided by 137 plus 5 would be 142. 3.5% of the occupations studied, women were out earning men. And so this tells a story. And the way you can use Python is to dig like this, to find out what the data wants to tell you, to bring it to life, to analyze it, and to help you visualize it. So I hope this gives you a sense for some of the things you can do. One other way of looking at this would be to generate a histogram where you compare F weekly with M weekly in terms of just buckets of values. And so this kind of gives the story as well. So the blue is female earnings, and you see that it's much more heavily weighed towards the lower end of the spectrum. It's like a decaying curve, actually. The male earners have a little bit more, they have more higher heights on the entire second half of the graph, right? There's way more men. In fact, some of these bars don't have any women. And women out earn men in the lowest paying. That's not a good thing, right? That means that the lower paid jobs are more being given to women, and the higher paying jobs are more being given to men. Now, obviously, you have to look at the source of the data and make sure the methodology for gathering this data was reliable and all that kind of good stuff. So this is more about how we're using Python than it is about this particular data set. But I think it's fun to look at things like this, which, can help you understand the world a little bit better. Hey, Jordan, welcome. One other thing you can do is, I've been focusing mostly on graphics, but you can also do lots of statistics in Python. So there's a library called SciPy, which has different statistical tests. And if you've studied statistics, there's something called a t-test. And the idea behind a t-test is if you have two samples and they come from the same distribution, a t-test will tell you what is the likelihood that they really did come from the same distribution, and you just got, by pure chance, those two samples.
Hi, Mark. Sorry about the delay. I was having some issues with the connection.
No problem, George. Glad to have you. So what this statistic does is it gives us something called a p-value. And the p-value is basically the probability that those two samples could have been acquired from the same distribution by pure chance. And the p-value here is 3.98. Let's call it 4. And this e minus 0.8 means 10 to the minus 8th. So that's like 4 times 1 100 million, 1 over 100 million. So 4 over 100 million. So it's a ridiculously small number. And what that means is that if these two data sets came from the same population, the probability of getting such widely divergent values is almost like the probability of winning the lottery. It's like incredibly low. So it says statistically, we can say with a pretty strong amount of confidence that these two distributions are. It's not like we just got lucky and we randomly got different values. The underlying probability distributions are different. They have different mean and probably different standard deviation. Okay, so that's it for the first example I wanted to share with you. Any questions on that? Okay, the next one I wanted to show you is a digit classification model. So this is more getting into the machine learning side of things. And I have to be careful when I do this because I could easily go off on a tangent on this machine learning stuff and run out of time to do everything else. So I'm going to try to go through this kind of quickly, but I've given you links to the slides and to a notebook where you can try some things for yourself. But the biggest idea that's come along in the last, I would say, 8 to 10 years has been this notion of neural networks. And neural networks are ways to train a computer to solve problems that we can't actually solve that well ourselves by writing code. And this diagram illustrates this. The way we've been programming computers for the last, as long as we've had them, 60, 70 years, whatever it's been, has been that we would take a bunch of data and we would code these rules for looking at the data and spitting out answers. And that works well for some things, but for a lot of problems, we're finding that this new technique of machine learning is producing much better results. And the idea with machine learning is you don't put the rules in, the computer figures out the rules. You give the software the data, and you give it the answers. So you say, this is a picture of a dog. This is a picture of a cat. And you give it enough of these pictures, and it figures out what it means to look at a picture and to decide what kind of animal it is. It's kind of amazing if you think about it. And if you think about trying to do that yourself, like write in Python a program that would look at an image and tell whether it was a cat or dog, it's an extremely hard programming problem. And no one's really ever solved that particularly well. This machine learning technique solves it extremely well, as well as humans, in some cases better. And I'll show you an example of how that works really quickly. Imagine you have this problem where you have a bunch of handwritten digits like you see on this screen. It would be nice if you could feed them into a piece of software and the software would tell you what digit you're looking at. Now we look at this and we think, well, this is trivial. Like this right here is a 5 and this right here is obviously a 7, but there's a lot of stuff going on in your brain to make that happen that you don't even realize. And again, programming this the old-fashioned way would be very hard, but using machine learning, this turns out to be quite doable and quite accurate, about as accurate as a human would be. What we do is we feed these kind of scribbled digits into the computer, and what the computer sees is a digitized version of that. So it sees a 0, for example, wherever there's white space. And depending on how dark a given what we call these pixels, coordinates in this grid, depending on how dark they are, we'll see a number between 0 and 1. So 1 means it's totally black. 0.5 means it's sort of like halfway between white and black, and so on. But you can see this matrix of numbers kind of models the shape of this thing, because that's essentially what we're doing. We're just taking a snapshot of the pixels in that graphic image. Then we take that image, and we kind of stretch it out from end to end, and we feed it into a mathematical function that multiplies every one of these pixels by a certain number and adds them all together. And we deposit the result in this node here at the end called 0. And this, to jump to the chase here, this node is responsible for estimating the probability that the incoming image is a 0. So we wire up all of these. I think that went, yeah, we wire up all of these to all 10 of these output nodes, we call these, or neurons. And by calculating these weights that we multiply these inputs by, we can have a different weight on every one of these paths. And by choosing the weights just so, we can get these output nodes to the point where they're very accurate, very reliably determining the probability of the number that's coming in. So I'm not going to go through the mechanics of how you do that. If you do the lab that I'm referencing there, it will walk you through that process a little bit more step by step. But it's a mathematical computation where you basically feed data in and you see how these probabilities come out. And you say, how close did this network get to what I know to be the actual truth? Because this is labeled data. When I feed this 8 in here, I know what it really is. I know it's an 8. And I see what was the probability for 8? It should have been pretty high. And what was the probability for these other things? They should have been low. And depending on what the answers are, you're going to fine tune all these weights, these 7,800 weights. And then you run it again, and you do it with a whole lot of data. And eventually these weights get fine tuned to the point where the estimates coming out of this network are very accurate for the entire set of training data. Another way to think about this is, imagine this is just a black box with 7840 knobs on it. And you're just turning those dials ever so little through every time you put data through. And eventually you get the dials to the point where the entire network produces greatly accurate estimates. And we'll go through the math that's going on underneath here. But yeah, I think I've covered enough of that. There's a lab I'm not going to go through in detail, but I'll just show you what it lets you do, because the idea here is to give you the chance to actually train one of these neural networks. I'm showing you pictures of them, but I wanted you to see how you would actually do it in Python. So this cell is just installing something called TensorFlow, which is Google's machine learning library. Sets some parameters, and then it loads in the data. And this data should look familiar to you. It's these handwritten digits that I just showed you. So you see that that's what, those are rendered by the computer. And sorry, I was distracted here. I thought I had a question from you all, but it's from, I think somebody left it in this lab. So we take this data. I have a few utility functions, which I'm not going to explain, but you can open them up and find out what they look like and what they do. But they're basically to make the training process easier. And now this is a neural network right here. This is like, what, 12 lines of code? And what it does is it creates 2 layers. You see the input layer is 28 by 28 by 1. Those are all those nodes I had on the left-hand side. And then we have a dense layer where everything from that 28 by 28 flattened list of pixels is densely connected to these 10 nodes right here. So these are the nodes on the right-hand side. And I'm representing this using Python code. I don't expect you to, process all this code you're looking at here. But the key thing is, I just want you to show that I'm calling a function. It's part of TensorFlow. There's the open brace. And what I'm passing to it is a list. So there you see the square brackets. That's what we've been looking at all along. That's a list of 2 things. The 2 things are layers. Layer 1 has this 28 by 28 by 1. It's actually flattening them. So it's that elongated list of pixels. And the second one is a layer with just a dense set of 10 output nodes with this something called softmax. That's the activation function that will give us a probability. So We compile the model and then we train it. Let's run that. The training process goes step by step. It's running through 937 pieces of training for each time through the model. The first one took not quite. I don't know why it's saying 34 seconds. It wasn't that long, but now we're getting about 3 seconds per iteration, and the accuracy is getting better. You see the accuracy here is 93%. It's 0.8 of the way through there. Now we're on the last, what we call epoch, which is entire pass through the training set. And that finished. And our final accuracy was 94%. And now what we can do is actually use that model. So that whole process was that turning of the dials. That was like taking this black box and finding these numbers that give us the best possible output. So I'm going to jump. This lab has you build better and better models, but I'm just going to jump to the end with this model. We're going to prepare it for use with a little interactive web widget. That should just take a second. And now I should be able to run my little web thing right here in the notebook. And what I get is the ability to take my mouse and draw anything. So I'll draw something that looks like a 3. And as I'm drawing it, you see the model I built is in real time giving you the output of those 10 nodes on the right. It's giving you these probability estimates. And it's very normal that it's not perfect, right? Like it really is quite certain it's a 3, but there could be these other things. And, you know, why is it not more definitive? I mean, it's pretty definitive, obviously, but why is it not perfect? Well, that's because I went with the simplest model just to get us moving through this quickly. But you get this idea that, you know, it thinks it's a 7. You can sort of watch it. It's pretty sure it's a 7. Now it thinks it's a 5. Hopefully now it realizes it's a 2. Now it's not sure if it's a 5 or a 2. So thinks it's a 3. Now it realizes it's a 2. So anyway, it's fun to play with because you can almost see the model thinking in real time. And I encourage you to take a try through this notebook. It may be a little bit advanced for you right now, but again, the idea here is I just wanted to show you that using some of the stuff you already know, your import statements, print statements, here's an assignment statement, a method invocation, here's a print statement. Using some of the basic things you've already learned, you can do things like this now. That's why a little bit of Python can kind of open up the whole world to you. How are we on time? I have another 5 minutes or so. So let's do the last example. This one's a little bit more fun. It's called style transfer. And I don't know how many of you may have seen this, but it's where you take an image and then you apply an artistic style from another image, and then it sort of morphs the two into a stylized version of the original image. So let's try it out. We'll import some dependencies, and again, we're importing TensorFlow Hub and Matplotlib to do the displaying of the images. We've got a utility function called image scaler. That's just taking an image and kind of cropping it and setting it up with the right ratio, with the right aspect ratio and size and everything else. So it's purely, you know, nothing to do with machine learning. It's just preparing the images. Load image takes a path to a website that has an image, and I'm going to use that down here to load the images. So here's one image. It's this URL here, which I can show you is me way too close up. And then here's another image, which actually I'll just run this code because it's going to display the images in line. Giving it these two images, calling load image with the path for both of them. I'm calling the first one content image and the second one style image. And then I'm just displaying the two images in this output of this cell. Just going and getting them the two, and there's displaying them. Okay, so the content image is me, and the style image is this painting by Van Gogh. Next thing we're going to do is load the model. So we don't actually always have to train a model. We can just load a model that someone else trained. And obviously this is nice because we don't have to do much work. All we have to do is, piggyback off of someone else's work. And so just like you can use Python code that someone else wrote, you can use a machine learning model that someone else trained. It takes a little while, so I should have started this while I was talking, but it's not too bad. Now, what's actually happening is it's loading those numbers. Really, what a model is those mathematical scaling factors that it applied, those weights that it applied to all those connections in that graph. So really, it's just a bunch of numbers at the end of the day. But the numbers are set up just so that they do a good job of solving a particular problem. And we'll see that now. Run this next cell. Let's look at what it's doing. Hub module is applying the model to two inputs. The content image is right here, and the style image is right there. So this is like taking those two images and putting them into the model, inputting them into the model. The result is right here, stylized image. It's just another image. And we show it using Matplotlib, put a title on it, and display it. So let's try that. And there it is. So I look a little weird, but you get the idea, hopefully. It's like if my headshot was painted by Van Gogh during this period, maybe it would look something like that. I don't know. I'm not sure how good that is, to be honest. But at least I hope it gives you the idea that you can apply these models that someone else wrote. You don't have to start from scratch. You can do things like this right in a notebook, in a Colab notebook, and we're not doing anything fancy beyond capabilities you've already learned in Python. And that takes us up to 7:48. The next half of the class, we're going to take our project from last week and add some new capabilities. So let's take a break. If anyone has questions, I'll stay on, and let's resync at top of the hour. Okay, I think we'll pick up again. I said the second half. If it's not really a second half, I'm not going to keep you 2 hours again. We'll finish up at 7:30 or 8:30 rather, in my time zone. Another half hour, basically. The next section I wanted to show you is basically taking the work we've done previously, that project where we built this kind of newsfeed application, and taking it to the next level. So one big kind of constraint with the version we had worked on up to last week was that it was sort of one monolith, or it was stretched across multiple cells in a notebook. And that's really not an optimal way to organize the code for a real world application. So it was like the notebook was artificially kind of causing it to have an organization that wasn't optimal. So this week I want to reorganize things, and we call this refactoring. It's just kind of restructuring the app to be more amenable to how we want it to look and work. And half the time this is about just making the code more understandable to other people. So the idea is we're going to break the app down into 4 sections. Imports to pull in the pieces we need. Config data, the news feed portion, and the web portion. So the imports are actually pretty straightforward, and we'll actually split those up across the other modules at some point. But let's just run that now. That's just importing all our dependencies. Now the configuration piece, I've generalized a little bit. So this is pretty much what you saw last week with one exception. I've made the storage engine more general. So we can store files in the local file tree. or in Google Drive, or eventually in Google Cloud Storage. And so the idea here is you set this storage variable to one of those three, local drive or GCS, and the storage functions will honor that setting, will automatically do the right thing. So this is a nice way to structure your code because you want it to be as flexible as possible. And we call this a build time setting. And by that we mean whatever I set this variable to, the program, the application that runs is going to kind of reflect that setting forever as long as it runs. So when I build it, I set it once and then it's going to take that setting. That's to be contrasted with a runtime setting, which is something where you can dynamically, each time the program runs, change things. And why might you choose one versus the other? Typically, runtime settings are for things that change frequently or that each user might want to handle differently. Build time settings are for things that the programmer wants to set. Like if I decide I want all my users' data to be in Google Drive, I'll set this storage parameter, and it's not for my end users to know about or to have a say, and it's just the way I want it to work. And so I'll use a build time setting for that particular parameter. The rest of this code is should look familiar. Save config writes the configuration data into a file. Load config reads it from a file. And the only thing that's different is now the file can be any one of those three data stores that I mentioned, local, drive, or GCS. And this reset config does the resetting. Just close my door. Now the next module I divided things up into, I called news. And this is all the functions related to actually getting the news feed. So these should also look familiar. I'm not going to walk through them because we visited them last week and the week before. Get new articles gets the news feed for one particular site and one particular topic. Get news uses for loops to iteratively call get new articles for a collection of sites and topics. So it's very straightforward. There's a for I in sites loop, and there's a for j in topics loop. And it calls get new articles I, j. And then display, if you remember, we had a display that we used for doing kind of text output, like a report generated right in the cell or on a command line basis. And then we had a function called display web, which would produce an HTML version of this report. And I decided I don't like display and display web because it's really doing the same thing, just two different flavors of it. So what I did was I created display with an argument that I pass called format. And the default format is HTML. When you put the equal sign in the definition of the function after one of these parameters, that sets a default value. So if you don't specify a format, it's going to assume HTML. You can also specify text. And this does the same thing as last week. If there's no articles, it says nothing new to show you. Otherwise, it sets report equal to table if format is HTML. Otherwise, it sets it to an empty string. Now, you haven't seen this particular version of an if statement. It's kind of like a one-line if statement. It's equivalent to saying if, let me do it the right level, if format equals HTML colon report equals whatever, else format equals null. And really, this is a fancy Python idiom for doing that if statement in one line. Okay, so if you prefer the written out version, please use it. It's whatever you're most comfortable with. I like keeping things terse, but that's all this is doing. Then it goes through the articles, and it says I've been asked to generate HTML, I generate these funny tags that will make the report look nice on a web page. Else, if I've been asked to produce text, then I use this f string, which we've seen before, that will just generate a nice text line of output. I increment my count, I keep looping, and then finally, again, I have an if construct. If I'm doing HTML, I have to put an end tag to this table to match the beginning table tag. And if not, I'll add nothing. I'll add an empty string. And then I return that string, and I've got something that I can display, one function I can call to generate either a text report or an HTML web ready, a report that can be rendered on a web page. So that's my news module. Now I've got the last one is I call the web module, and this is just my web server. It's quite short. It's using this Flask library I showed you earlier, and it has this one function that goes and gets the config data, then it gets the news, and then it filters the news to make sure I haven't already seen it, this article. And then it displays, it's calling this new display function. Since I'm assumed to be web here, I could hard code this to say format equals HTML. I don't technically have to because I made that the default value, but maybe just to be safe, I guess in theory, someone could change that default at some point. So, and I know I always want HTML because this is part of a function that's specifically serving this app for web clients. And so I'm going to make this explicit and say format equals HTML. So I'll run that, and I don't know if I remember to run this one. I'll run that cell. Now nothing happens, and that's because all I'm doing here is defining functions. Nothing's actually doing anything with those functions. Now we can actually do something with it. So let's first test it locally. And first we're going to do this, reset the config. We'll say get news with whatever we've loaded it up with. I think the default config is the Guardian, one site, the Guardian, and one topic, tech. So we'll do get news. We'll get the results in this list of articles. And then we'll pass to this display function that list of articles. And we'll say we want it formatted in text format. And we'll get back a string. And then we'll just print the string. So let's see if that works. And we get back what we expected, a numbered value for which story we found, the title or that like the headline of the story, and then a link to the underlying website that has that story. So that looks like it's working nicely. We got 52 hits. Now let's try the web version. So we'll run this. What this is doing is calling this app run. There's a little bit of magic here because we're in a Colab notebook. But I think we saw this last week. If I run this, it gives me a link that I can click on to get to the running web version. And this is going to cause it to do the HTML, the display the articles with HTML. And as you can see, I get the same hits, 52 articles. The last one is Instagram at 10. And because I'm taking advantage of HTML, I can combine the links with the titles in this nice succinct format. So I'll just click on this link and I get the Instagram at 10 article, sure enough. Obviously, it's not a super impressive web display. I haven't tried to do anything with the UI look yet, but you know that's something I can work on down the road. If I reload this web page, after it displayed this, it's kept track of everyone I've seen here. So if I reload this display, I get nothing new to show you, and that's because there are no new stories in the last however long from now to when I last drew that page. And I could keep doing this. I'll keep getting nothing new to show you until the Guardian suddenly publishes a new piece on tech. If I wanted to reset things, I could just stop this cell, rerun it. And that, of course, has this reset config line, which is going to reload the default configuration. And now if I visit that site again, I get the every story that's out there right now. And that's because it forgot all of the scene. It when it reset the config, it reset all of the memory of which stories it's already seen. So hopefully that makes sense to you. Now what you could do is you could deploy that yourself outside the notebook. And I'll just show you quickly how I would do that. I would go into this Mu editor and I would say new file. And in the place of the first file, I would just copy let's take the news functions, for example. I would take the news stuff, I would paste it in there, and I would save it and call it news.py. Here's the web piece. I'll put that in a web.py. Save that in web. I don't actually have to say pi. I think it does that automatically. So you get the idea. You could put the imports. You probably don't want to put. Let's finish this. Config. We'll put into config.py. And I kind of encourage you to do this yourself. See if you can get this app working on its own in Mu. I'll say save, and we'll call that config.py. And the last thing is the imports. We're not going to import, so I'm going to sort of distribute those accordingly. So what do I mean by that? Well, the web piece needs Flask. So we'll just import Flask there. You don't need this collab stuff. The JSON and OS is used by the config piece, so we'll move that in. So there's a little bit of sort of messing around you'll have to do with these imports, but it shouldn't be too hard. And then where was it? Yeah, the news catcher and describe URL is used by the news module. So let's add that to the top of news.py. And now I think we should have everything. Let's save this. And now let's run, let's create a main. There's nothing running anything here, right? There's just a bunch of functions. So let's create a main that says app.run. And let's call this main.py. And let's run it. It says name app is not defined because I need to import, let's say from web.py import star. And that's because this app right there is defined in the web component. I need to import it into main if I want to use it. Let's save that and try running it again. No module named web.py. Web is not a package. Okay, so I didn't need to say .py there. Save and run. And it seems to have run. Let's take this, it spit out this URL. Let's try putting this into our browser. And we got load config is not defined. So you see, we're like working our way one step at a time. And you can sort of guess that by looking at this output, something in the web component, and I'm assuming it's the web component because this error is coming from the Flask package, which the web uses, is not happy that I'm calling a function called load config. So that's because if I go to the web piece, doesn't have access to the config data. So you see right here, it's using load config and save config, but it hasn't imported that. So let's say from config import star. And remember, config is just this file. So now we're doing imports from one of our files to another one. Save this. Let's try running it again. Not sure. Oh, I'm running the web.py, and I really want to run main.py to get anything interesting to happen. Okay, let's go reload. And I may cheat if this doesn't, so we're on to another one. Now, web.py is missing get news. So what does that tell you? That tells you this guy needs access to the news module. Remember that news module has our get articles and it all Well, it's right here. It has get news, get new articles, and display. So the web guy has a call to get news. So just like it needs config, it also needs the news. So we've done that. Hopefully we're getting close. Did the same mistake. Go to main, run main, reload, and config data is not defined in the news module. So hopefully you're getting the idea that you need to figure out everything you need and include it. From config import star. I need anything else? Don't think so. Let's go to main, run it. Broken pipe. Okay, I am not going to try to debug this because it will kill the whole rest of the session, but I invite you to try this, see if you can make this thing work outside of the notebook, and maybe consider that one of your homework problems for this week. I actually think I'm really close. Oh, I think I see the error right here. Address already in use. So I think I'm running it somewhere. If I do look for Python. Yeah, it's running now. Kill. $82021. Now let's try to run. Okay, it actually worked. Now it wasn't very exciting because it said nothing new to show you. But what I'm going to do is remove that file, that config file, and it should suddenly start showing me stuff. So I know I said I wasn't going to do this, but I'm too close to stop now. Code, my news feed. Here's where mu code keeps everything. And here's my news feed config file. And you see it's got all those scene URLs. So I'm just going to clobber it. Actually, I can just clobber the scene stuff. So I'm going to edit this to make this empty. And I think that should do it. Actually, I can just get rid of it and redo it. Okay, and now, as you see, now that I've reset the config, it's giving me all 50. Not sure why it's not scrolling, but it's giving me all the articles again. And if I reload it now, it'll say nothing new to show you. So I've got it working in Mu, and I invite you to do the same thing. I said I was going to try to deploy this to the web. Let's see if I can do it in 10 minutes. First of all, I put all this code in a GitHub repo. And if you don't know what GitHub is, it's kind of a coder's website for collaborating with other people. So here's my code. I put it up in a site called mynewsfeed.io, which is the domain name I'm going to use for the web page that I put this on. And you'll see here, here's main.py, which should look familiar. Let me blow this up. Config.py, all the files we've been playing with are now stored on GitHub. And so as a result, you can actually check out a copy of this code. And actually, that might be a better way to do it than the way I just showed you of kind of copy pasting everything. But we can actually check it out right inside this notebook. So if you want to reproduce this step, you have to go to Google Cloud and set up an account, because the way I'm going to deploy this is in Google Cloud. I'm not trying to talk anyone into using Google Cloud. There's a lot of different ways to serve up websites, but this is just the one that I like best. And I have the wrong URL there, but it's cloud.google.com/free, and I'll fix that link. If you go there, you can get $300 worth of credit in Google Cloud. You have to enter a credit card, so it's not, if you're not comfortable with that, that's totally fine. But at any rate, if you do that, then you can set up an account in the Google Cloud and create a project. And then you can start running these commands locally. So one I'm going to run first is gcloud init. And that's where it just prompts me for a few things like, do you want a new setup or kind of reconfigure your existing setup? It says, which account do you want to run with? And I say my standard Gmail account. And then it says which project. I have a bunch of projects, but the one I want to use for this is called mynewsfeed-io right here, which is number 35 in that menu. So I'll say 35. Now it says you're all set. So I'm using this account, my Gmail account. My project is set to that in Google Cloud. And I'm now ready to use a service in Google Cloud called Cloud Run, which lets me deploy websites. And so first I need the source code. I know I have it in cells in this notebook, but I need it in a place where I can easily just push it up to the cloud. So I'm going to do this git clone command. And this is what I said earlier about checking out somebody's repo. This just gets me a local copy of all the stuff in that repo. And it's telling me that it already exists, so I don't need to worry about it right now. But if I actually wanted to verify that, I could say !ls my star. And it should list the contents. There it is, mynewsfeed.io. There's all the files that I just showed you. And now what I'm going to do is run a script called rdeploy. And what rdeploy is going to do is push this code into the cloud. Now, what does that mean? If I go to this cloud console, and that's once you have an account in the Google Cloud, you can access this console page. And this is where you can administer everything about your cloud profile. And so, for example, what I'm going to do is I have many projects. I'm going to set the project to mynewsfeed.io. And then I'm going to move to a particular service that I'm going to use called Cloud Run. And Cloud Run is a cloud service for running websites, basically. So you can see here's my, let me blow this up. Here's my site. And the way you create these services is quite straightforward. You say, you know, where do you want it to run, what region, and they have, you know, Europe and Asia Pacific and so on. You name the service name, whatever, and you say, I want to allow all authenticated, or you want to require authentication. That's basically saying, do you want somebody to have to log in or just give them access immediately? Configure various things about it and so on. I'm not going to actually create a new one. I'm going to do it by command line from the notebook. And if you do this with your own account, you should be able to do this yourself, but let me know if it doesn't work for any reason. The magic in the next step is this rdeploy script, and I can show you what that is, what that looks like. I'll show it to you down here in the right directory. That's going to take a little while because it has to do a bunch of things. This is not a great example because it's the way these notebooks work is it does everything in the cell and then it shows you all the output at the end, which is annoying. Okay, here it is. So this is what the script looks like. Ignore this. This is just setting variables, but it's using something called Docker to build kind of a module, encapsulated version of this application. The real, heavy lifting is right here. gcloud run deploy. This is saying, take this app and deploy it in the cloud in this one command. There's a bunch of things I'm adding This is all configuration stuff. And then from that point on, it's not working because it's not finding Docker. I'm not sure why. So I'm going to have to figure that out. But at any rate, once you deploy it, you get a URL that you can click on. And if you click on that link, it runs. And that is now running on the cloud. So if you were to click on that link, you would see the same experience. But that's not a very nice URL to have to type in. And so what you can do from this cloud console that I showed you, I've got too many tabs here, is you can say manage custom domains, and that gives you the ability to assign a specific domain name to your service. And what I've done is I've bought this name, mynewsfeed.io. I think it was $10 a year or something like that, not too bad. And I've applied it to this Cloud Run service. And now instead of having to type in that long cryptic URL, I can type mynewsfeed.io and I get the site. And if I reload, I should get, I was expecting to get no new news for you, but I think what's happening is every time I end up on a different server, it's starting over again. And so some of you may get the no news. Actually, I think I might have made a change to this code, and that might explain why it's doing that. Yeah, let me try rerunning our deploy, but I'm going to do it locally because it was, I'm in the wrong directory. I'm in the mu code directory. My newsfeed. So running the R deploy in the notebook was a little bit artificial. I'm going to run it here locally, and you can watch it run. I think once this version gets pushed, it will actually do the keep track of where I've been before. So that was building and pushing the container, what's called the container, which is kind of, like I said, a modular version of our application. Now it's doing the gcloud run deploy, and you can see how long this takes. It takes the container and just sort of sends it up to Google, which is already saying the deployment's finished, but it's got to kind of set up the traffic to be routed to the new app. This should take just a few more seconds, and it's done. So I get this URL. But what I really want to verify is if I go here to mynewsfeed.io, it takes a little longer, and that's because it's reset everything. But now if I reload, I get nothing new to show you. So I had a version of the older version of the software up there that wasn't doing the right thing with keeping track of where you've already been, but now it's up there. So I invite you to visit this site. I think you'll see it say nothing new to show you for now. So it won't be terribly exciting, but if you try it in a few hours, you'll probably see another new article or 2 or 3 or 5 or whatever. In fact, I'll set it up with a bigger set of sites and topics so that it gets updated more frequently. But anyway, that's kind of takes us to the end of this lesson. The homework for this lesson is down here. As usual, make a copy of this notebook and kind of work through it on your own. If you have trouble with the deploying to the cloud piece, I won't be surprised because it's tricky, but let me know if you have trouble with that and I'll help you out with it. I've got 2 articles I recommend. One is on pandas and the other is about machine learning in general. And they're both kind of for beginner level folks. And so they hopefully won't be too intimidating, but we'll give you the second one in particular will give you a nice overview and tour of a bunch of things in machine learning explained in a really nice sort of visual way. I'll just show you what this looks like. Yeah, it's nicely done. And then lastly, officially I said this was going to be an 8-week course. So, you're not on the hook for any more lessons, but I also want to give you an opportunity to take the next week if you're interested on and work on a project of your own design. It could be anything. It could be a data science type thing. It could be a web app. It could be just a simple command that prompts you for input and does something fun or game-like or whatever. So I'll leave that for you to decide. If you don't hang in for the next week, that's fine. I know everybody's pretty busy, and I hope you got a lot out of this class and it was helpful. If you do, then I'll see you next Wednesday. And in the meantime, between now and then, if you start a project and need some help, if you get stuck, please reach out to me, and happy to set up a quick meetup or answer some questions by email, whatever it takes. And I think that's it for tonight.
Thank you.
Thank you, Mark. Bye.
Bye. Bye.
Goodbye.
Bye.